Hey guys, we're moving on to section 6.3, which is conditions for parallelograms. So in the last section, we started with, hey, this is a parallelogram, so we get to use all these cool properties. Now we're actually doing the opposite. Excuse me. So now we're actually going to say like, hey, it's got this property, so it must be a parallelogram. All right, so if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Okay, so the key part there is that it's one pair and they are parallel and congruent. It's not, oh, one set's parallel, one set's congruent, okay? It has to be the same. So when we look here, BC is congruent to AD. That's the tick marks. And then BC is also parallel to AD. That's those arrows there. Okay, so one pair of opposite sides that are parallel and congruent, that gets us a parallelogram. Okay. Also, we've got if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so when we look at this picture over here, we've got AB is congruent to CD. Those both have one tick mark. And then we've got BC is congruent to AD. Those both have two tick marks. All right, so both of these are just properties that we had before, right? We started with if parallelogram, then both pairs of opposite sides congruent. So we're just saying that the opposite is true as well. If we have both pairs of opposite sides congruent, then we get a parallelogram. Okay, that's all it is. Super easy. We're moving on. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Might help if I could spell parallelogram correctly. The key word for this is again both. Just like in the last one, both pairs of opposite sides congruent. This one is both pairs of opposite angles congruent. That gets us a parallelogram as well. So over here we've got angle A is congruent to angle C, and we've also got angle B is congruent to angle D. Okay? The key word again for both of those is that it has to be both. It's not one pair of opposite sides congruent. That doesn't get us a parallelogram. It has to be both. Moving right along, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Okay, so just because it's supplementary to maybe one consecutive angle doesn't mean that it's a parallelogram. All right, an angle has to be supplementary to both of its consecutive angles. And remember, supplementary means that they add to 180 degrees, and consecutive means that they are next to each other. Right? Opposite means across, whereas consecutive means next to. Okay? So if we take a look here, angle A is x, angle B is 180 minus x, and angle D is 180 minus x. If that happens, then we get a parallelogram also. Okay? And one more condition for us. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, and it does have to be that both of them are bisected because they bisect each other. So taking a look at our picture here, we've got AZ is congruent to ZC. If those were the only ones that were marked, if we didn't know anything else, we would not be able to say that it's a parallelogram. Okay, we would have to have BZ congruent to ZD as well, which in this picture we do. So because the diagonals are bisecting each other, it is a parallelogram. If they only bisect one of them, if one of them only bisects the other, then that's not a parallelogram. Okay? That's it. All right, we are going to use all these properties then to look at figures and decide if they're parallelograms or not. So take a look. We've got our learning target up on top. Excuse me, I'm so sorry, you guys. And we are going to determine whether the quadrilaterals are parallelograms, and we're going to justify our answers. So taking a look at question 1, if we look, we can see that this diagonal is 6 and this diagonal is 6. So I'm going to put 1 tick mark on both of those. And these ones are both 3, so I'm going to put 2 tick marks on those. Okay, and if we look, we can see that those diagonals are clearly bisecting each other. They're both cut in half. So this one is yes. If diagonals bisect each other, then parallelogram. Okay, so we can shorthand it. It does not have to be exactly as long as all of the conditions on the first page. But we do have to make sure that we include these keywords, right? It's got to have if and then, because that means it's a condition, right? It's a justification. Diagonals bisect each other. It's not just if diagonals bisect, then parallelogram. They bisect what? You have to tell me what they are bisecting. So it's if diagonals bisect each other, then parallelogram. Okay? The second one, if we take a look, we've got angle E is 130 degrees. We've got angle F is 50 and angle D is 50. Well, angle E is right here. F is consecutive to that, and so is D. And we know that 130 plus 50, those are 180. So that angle right there, angle E, is supplementary to both of its consecutive angles. So this one would be yes. And this is if an angle is sup to both consecutive angles, then a parallelogram. Okay, so again, we can shortcut it, but please make sure you include those words. It does have to be sup to both consecutive angles. All right, that does have to be there. All right, taking a look at number 3, we've got some congruent angles going on here. We've got that this 114 is congruent to this 114, and 66 is congruent to 66 down here. But in order for a figure to be a parallelogram, we would have to have opposite angles congruent, and that's not happening here, right? So this one is no. Now, anytime we have a no, your justification doesn't necessarily have to be in an if-then form. If you want to write it in one, you can. But in this case, we can just say no, opposite angles are not congruent. Okay? We would have to have opposite angles congruent in order to be a parallelogram. Cool? You are going to do number 4 on your own. So take a look at number 4, see if you can figure out whether this is a parallelogram or not, and write down your answer. Hopefully you can look at it and figure out that yes, it is a parallelogram, because if both pairs of opposite sides congruent, then we get a parallelogram. Okay. Taking a look at number 5. Number 5 is markings that you need to be pretty familiar with. We've got tick marks, which mean that those are congruent. We've got the arrows, which means that those are also parallel. So this is that very first condition that we talked about. This one is yes, because if one pair of opposite sides are parallel and congruent, then we get a parallelogram. Okay, the thing we have to be careful about is if we have a parallelogram that looks, or a figure, excuse me, that looks like this, and let's say we've got these ones are marked as congruent, and these ones are marked as parallel. That's not the same figure that we have here, right? This one has one pair of opposite sides that are parallel and congruent. This one has one pair of opposite sides that are congruent, one pair of opposite sides that are parallel. That one, without any more information, we would not be able to say is a parallelogram. Okay, so please, please, please make sure you're looking at your diagrams carefully. And last but not least, question number 6. This one is a little bit harder to see, so you got to bear with me for a second. But if we look, we've got, ooh, this should have a C on it. Angle CBD has one arc mark, and angle ADB also has one arc mark. So when we take a look at those two angles being congruent, it's a little weird, but you got to think back to chapter 3. I'm going to draw in some lines here. And a transversal. And if we look at those purple angles that I colored in there, or that I marked, if those two angles are congruent, those are opposite interior angles. So that actually tells us that those two lines are parallel to each other. Okay? We can do something really similar with these other angles. Angle ABD, so I'm going to color that one orange for a second, and angle CDB. So those orange angles that I drew in there, those are made up by this line, this same transversal, and this line, which then actually tells us that these orange lines are also parallel to each other. So now when we look at that, we have two pairs of opposite sides that are parallel. So this one is actually a yes. And it's if both pairs of opposite sides, oops, I forgot the word pairs. Both pairs of opposite sides are parallel, then we get a parallelogram. Okay, that's the definition of a parallelogram, right? So that's clearly a condition that we could use to prove that a figure is a parallelogram. So make sure that you are looking at these figures carefully. We will talk about any questions that you guys have in class. You'll get lots of practice, and we will get you ready for your quiz that's coming up in a couple of days. All right, I'll see you guys later. Bye.